Having a solid understanding of units is crucial in our study of mechanics and engineering in general. What units allow us to do is quantify different physical properties such as mass, length, force in a consistent and meaningful way. Now, typically, we'll work with multiple unit systems. In mechanics, we'll generally work with SI or international units, and we'll also work with English units. Now, what you'll probably find is you'll enjoy working problems that are in SI units a lot more than you will in English units because the units are just easier to work with, easier to convert between. But in practice, English units, some fields still use them. So especially in the United States. So we will work problems and examples using both types of unit systems. So the first thing I'd like to do is go through both of these unit systems and talk about what their base units are. So if we have a length, in SI units, we'll use units of meters. And we can abbreviate that with a lowercase m. In English units, we'll use units of feet. And we can abbreviate that with FT. The next quantity will be mass. And in SI units, a mass is represented with a kilogram. We can abbreviate that with kg. While in English units, a mass is a unit of slug. Now, the third quantity I want to talk about is time. In time, in both systems, is seconds are used. So we use seconds in the SI units and in English units. And it's a lowercase s for an abbreviation. And then finally, I want to look at what a force is. In SI units, a force is a unit of a Newton. And so Newton. And in English units, force is a unit of a pound. So Newton is a capital N, pound is a lowercase lb. So now that we have all of these different quantities, we can talk about what a fundamental unit is and what a derived unit is. What a fundamental unit is are quantities that are not dependent on any other unit. And of the ones that we've listed here, length, a mass, and a time are not dependent on any other type of unit. So our fundamental units are really our building blocks. The other type of unit that we have is called a derived unit, and a derived unit is created by combining fundamental units. And in this list right here, a derived unit is going to be a unit of force. And a unit of force, which we said, let's look at the SI unit. We have a Newton, and I'm not going to derive it here. I'm going to have a different video for that. But a Newton is going to be equal to a kilogram meter per second squared. And if you look at what the Newton is made out of, a kilogram right here is a unit of mass. A meter right here is a unit of length. And a second right here is a unit of time. So this derived unit of force is made out of fundamental units of length, mass, and time. Now, one of the most common mistakes that I would see was students confusing kilograms and students confusing pounds because of the way we measure things in our life. I don't necessarily mean if, say, you were given a problem in SI units, you would use pounds in the SI units. That's not really the mistake I would see. But what I would see would be treating mass like kilograms like a force or treating force like a mass. And both of those are wrong. Now, mass is a measure of how much stuff an object has, and it's going to remain constant. And force is a measure of the gravitational force on that object, and that will change with gravity. Now let's just look at the values that gravity has in these different systems. So in SI units, we have a value of 9.81 meters per second squared. And in English units, we have a value of 32.2 feet per second squared. If we look at this unit right here, we see that this is a derived unit because we combine different fundamental units, specifically our length and our time. And if we look at it a little closer, length per time squared is going to be an acceleration. So gravity is just an acceleration. Now, sort of an interesting note about these values, we're assuming that we're on Earth in probably all of the problems that we're doing in a statics, a dynamics, a fluids course. Uh, and those values are valid for Earth. And the last thing I would like to say is you should really make an effort to memorize these values. Because they're going to be very important in your engineering classes in general.